Hello, I'm Dan,
And I'm Leon.
and today we're going to be talking about living with legacy code. So, firstly, if we can get to the next slide, what is legacy code?
So we have a description that was given to us by Michael Feathers in his classic book, Working Effectively with Legacy Code, and he said legacy code is simply code without tests.
Yeah.
He based this on the observation that change is far easier when you have a solid set of tests behind the code.
Right. He also said this: legacy code, the phrase strikes disgust in the hearts of programmers. It conjures images of slogging through a murky swamp of tangled undergrowth with leeches beneath and stinging flies above. It conjures odours of murk, slime, stagnancy and offal. Although our first joy of programming may have been intense, the misery of dealing with legacy code is often sufficient to extinguish that flame. I think I can definitely attest to this. I think we all as programmers, enjoy the process of creation and making code do what we want. But when we get thrown into a legacy code base, it does extinguish that flame, and you begin to sort of start getting to the point where you just can't face it anymore.
And this definition of legacy is a bit weird when you think about how the rest of the world regards the word legacy. If you think back to the summer of 2012 when Britain was in the thrall of the Olympic Games, we were talking about an Olympic legacy, but when Boris Johnson and Sebastian Coe talked about the Olympic legacy, they weren't talking about slogging through murky swamps, although it was in Stratford, so there are areas like that. No, they were talking more about leaving a legacy to inspire people, to inspire kids to go running and jumping over things and getting fit. Last year at Aloha RubyConf, Chad Fowler described legacy code as code you leave behind to those who come after you. So this begs the question, why do we see the stuff we're leaving behind as tangled undergrowth and swamp with leeches and things? Why aren't we proud of it?
So, how would you define legacy code?
We decided to go out and ask a few people on the interwebs.
And here's what we found. So, Ed S on Google+, there are people on Google+, it's true, I found them. He said, for me, legacy means some form of abandonment. And I think I'm inclined to agree with him on this one. So we have our little obligatory, sad cat, poor thing, it's been abandoned. He also goes on to say, whether the original team is gone, the language is dead, or the original platform survives only in emulation, maybe several layers of emulation. I think he had a really interesting story, whereas the code he worked on was a system that I think was from the 50s possibly, and it only existed on an emulator, which itself was only existed on another emulator, and then on some real hardware. So I think that's the most extreme example of dealing with legacy code I've heard. But moving on.
So Peter Olsen went on to say, legacy code is, I didn't write it, I therefore don't want to accept the blame.
Yeah, I think this is a bit of the programmer, like the not invented here syndrome. We get a bit annoyed and upset when, we didn't write this code, but people ask us about it. And we're the payments team at 7 Digital, and none of us have been here that long. We certainly didn't write a lot of the code that we have to maintain. And we always say, oh, it's rubbish, it needs a rewrite. Oh, you're never going to be able to change that, it's all really bad. But it doesn't seem to take too long. You don't have to have been at a company too long before they start to think that you do in fact own that code and that you do write it. And all the problems do indeed become yours.
But let's look at Peter's other point, I therefore don't want to accept the blame. The first few days you're at a company, there's bugs coming in that you don't quite understand. As Homer Simpson put it, it's my first day. But moving on, you do get to the point where it is your code, and once you've left the company, is someone in the future going to say the same thing about your code?
As Bart Simpson says, I didn't do it.
So we wondered what this sounded like to customers. Dan spoke to a product owner that he used to work with.
Yeah. So I used to work with Danielle, and she said that in her experience of legacy code has been that it causes something completely unforeseen and unrelated to break when it's touched, even if the piece of code being worked on has nothing to do with that bit of functionality that broke. I think I can definitely attest to this. Leon, do you want to tell the tale?
Well, yes. So late last year, we had a perfect example of this. We kind of refer it now to it as the case of the infinite vouchers. So we heard that customers had vouchers that on some occasions were never running out. They would buy products off our website, they would use a voucher, but the value of that voucher seemed to remain constant. It never went down. Clearly something wasn't working, but we weren't sure what. So we asked the customer, how long have you been seeing this for?
Just a few days. Just a few days.
A few days, we thought. But we've not touched vouchers for years. In fact, none of us on the team had actually worked with the voucher code.
It was written in 2005.
There you go. So we had no choice. We were gonna have to put our waders on and go down into the legacy swamp. And we spent a day or so digging around the system trying to work out what was going on. And then we found... Well, we didn't actually find it. We were talking to some of our fellow coders, and they'd been working on a completely different area of the code. And they changed something in the last couple of days. Couldn't have been, could it?
Surely not.
Turns out that yes, indeed. That change had a knock-on effect in a completely different part of the system that we hadn't been working on, and had assumed that because we hadn't worked on it, it'd be working fine. We learned.
We learned the hard way indeed. So we fixed that, so you can't do that anymore.
Yes, so sorry about that.
Okay. So another thing that Danielle said is that to her, legacy code is technical debt with a variable and unlimited interest rate. Bitter experience has taught me it's a small price worth paying off sooner rather than later.
So Dan, I think we need a definition on this. What is technical debt?
As with seemingly everything, apparently Ward Cunningham coined the term, and I shall now read what he said, basically. Shipping first time is like going into debt. A little debt speeds development so long as it's paid back promptly with a rewrite. The danger occurs when the debt is not repaid. Every minute spent on not quite right code counts as interest on that debt. Entire engineering organizations can be brought to a standstill under the debt load of an unconsolidated implementation, object-oriented or otherwise. Oh dear.
Okay, so Ward talks in terms of you take out a debt and have to repay it. So what kind of forms can this debt take? Martin Fowler, who likes a quadrant, so I've heard, put together a technical debt quadrant which kind of outlines this in a bit more detail.
Yep. So in the upper right we see the ideal form of technical debt, and it's basically both deliberate in the upper quadrant and prudent over to the right. And this is basically saying we must ship now and we will deal with the consequences. So this is going back to the intentional, what Ward was saying, intentionally going into debt. We are actively going to create ourselves debt that we will repay, but we want to get to market faster. We want to hear and learn from our customers, and we want to be able to respond. So this is both deliberate and prudent, an intentional decision with the idea of paying back the debt afterwards.
But what if you're kind of shipping and not really thinking of the consequences? That's a bit more reckless. You're still being deliberate. You're deliberately saying we don't have time for design. Yeah. But you're being a bit reckless about it. So basically what this quadrant is saying is that look at the technical debt that you're taking out and make sure that you know of the consequences you're going to have to deal with. Okay, so that's deliberate.
There's also inadvertent. So down in the bottom left, there is what is layering. You basically, you're both reckless but inadvertently so. You just don't know what layering is. You don't know what good object-oriented design is. How you ever, you don't know any better. So therefore, that's the sort of the reckless, inadvertent form of technical debt. And there's also...
So you can prudently be inadvertent, if that makes any sense at all. Let's think that, like the person that didn't know what layering was, they didn't know what layering was, but learnt a lot while they were actually doing that first implementation. You can prudently say, right, I'm going to do this, learn from it, and then I'll know what I should have done and go off and do that.
Yeah, I think, this often happens when you come to the end of a long-standing project or piece of work. At that point, you know the most about the system. And I think we all have that bit where we say, oh, if I could do this again, I would make these changes. So this is prudently, both prudent and inadvertent.
Okay, so we're basically saying that be sensible about the debt you take out. Bob Martin has a thought on this.
As always, he says a mess is not a technical debt, a mess is just a mess.
He goes on to say that basically legacy code, this swamp that we've been talking about, is just a mess with no intent behind it. Technical debt decisions, Bob says, are made based on real project constraints. They are risky, but they can be beneficial. The decision to make a mess is never rational. It is always based on laziness and unprofessionalism and has no chance of paying off in the future. A mess is always a loss.
So if you don't want Uncle Bob to call you unprofessional and lazy, be sure not to create a mess. Make sure you're going deliberately into technical debt with the full intention of repaying it in the short term. And I think this is really difficult because quite often, you work for a company and you get something out the door because you have to meet that deadline for that customer, and then you say, okay, now we need to improve this. We did a bit of a hack, and the business is like, well, no, that's fine. We need to move on to the next important thing. So it's about making the business aware that it's a short-term debt. We have to pay this off.
So that's technical debt. Let's go back to what we were saying in the first place about legacy code being code without tests. This was way back in 2005. JUnit had only been around for a few years and TDD wasn't as embedded as it is now. Now we have whole suites of unit tests, acceptance tests, end-to-end tests. Does it help? Does having a suite of automated tests help when changing systems, as Michael Feathers said back in 2005?
Yeah. And also, has having a test suite ever hindered changing a system?
So we started thinking about when tests don't really help you as much as what we'd hoped. Let's have a look at some of those instances when they just don't help as much as they should.
First up, the tests are out of date. Features change, updates happen, but no one seems to update the tests. We've often found that we found code basically that is only in the live system because that there's a test still around it. So it's basically as a result of the tests being out of date and code being kept in them in production purely for the sake of a test that's not actually used, or the code for that test is not actually used.
And it's business features that aren't needed anymore. Dan gave me an example a few weeks ago of some code that was actually decorating windows based on what season it was, so Christmas you'd have snow, that kind of thing. This feature everyone had forgotten was actually in there. Nobody was selling it anymore. Why wasn't it removed? And for that matter, why weren't the tests removed as well?
And it's an interesting one because if you say to the business, did you know that there's some code in there that will put Easter eggs around something at Easter and snow at Christmas? And they're like, no, I didn't. But that's a feature. You can't remove it. That's an asset. Or is it? Or is it a liability? I asked that question. Anyway, moving on.
Tests don't convey the intent of the system.
So often you can find tests that say something along the lines of should return 400 when given 5, and you look at it and you're like, what does that mean? Often they're so granular that tests just don't give an intent as to what the system does. In that example, is that like a mortgage calculation? Is it an interest calculation on a loan? We don't know, and we can't glean it from the names of the tests. So I think it's important that we try and convey the intent of a system with our tests and their naming and how we structure the project. Okay. Tests are slow.
This is the old classic. As we build up suites and suites of tests, you've got thousands of the things. We find that they just run slowly. Sometimes there's lots of dependencies. Occasionally you'll have integration tests that rely on a big database that needs setting up. I'm sure everybody listening to this has experienced this in some way. Why is this a problem? Well, the slower the tests are to run, the less likely you are to actually run them and actually listen to the feedback that they give you. Remember, Michael Feathers was saying that code with good tests is easy to change. But if you're waiting half an hour for the tests to come back, that's going to slow your rate of change down.
I mean, they say a good test will run in under 10 seconds. I would be happy with under half an hour. It's just too slow. Okay. Tests are brittle.
So, how often have you heard this at work?
Leon, the tests, they're all red.
Which bit of the test is red?
Oh, it's the acceptance tests in the user acceptance test environment.
Oh, those acceptance tests in the user acceptance test environment. Yes, I know those. Don't worry about them. Seriously, run them again and they'll be fine. If they're not, just run them again. Eventually, they'll all be green.
Fantastic. Cup of tea?
Why not? It's going to take half an hour for the test to run anyway.
Excellent.
So yeah, if you don't believe what the tests are telling you, why have you got them there in the first place? Are these flaky tests actually hiding a real bug that's in there?
Yeah. High coupling between tests and app code.
So tightly coupled tests make refactoring production code difficult. As Mike Feather said, good code has tests, so we can refactor safely. If we've got a high coupling between the tests and the application code, then that refactoring is going to be a little bit more difficult. And the whole point, after all, was to have easily changeable code, and that's difficult with tight coupling. We know coupling is bad, so let's try and avoid coupling tests with application code.
Yeah, I mean, just to reiterate, the whole point of tests is to make it easy to change a system. So if adding so many tests or coupling them so tightly makes it difficult, then we've kind of defeated the purpose.
So how do we solve this? Well, what we're proposing, or what people have proposed, is you introduce test refactoring as part of your test-driven development cycle. So everybody knows the old classic of write a failing tests, get it to pass, then refactor the code, and just keep going around that loop. What we tend to forget with that is that also the tests need a bit of a refactor as well. We're not saying do it every single round of the cycle, but maybe once a feature has been added, have a look at the tests. Ask yourself a few questions. Are they slow? Can we speed them up?
Do we need them anymore?
Is there an overlap? Do multiple tests actually test the same behaviour? And are they too strictly tied to the implementation details? Are we testing the implementation, or are we actually testing the behaviour, which is what we really should be doing? And this case, when tests are very strictly tied to the implementation details, is very common when you're using mock objects, and you find that there's about 5 different expectations set on each mock object, and that order is really, really important. So you swap the order around and suddenly you've got a failing test. That's too coupled.
Okay. So what practical steps can you take when changing legacy code?
So Mike Feather's book has got some really useful tips for getting code into tests. But you look at this big swamp, this big ball of mud, it can be quite intimidating. How do you even start?
Yeah, I mean, so here's some of our experiences. So firstly, we're the payments team at 7 Digital, as I've said, and to be honest, we all inherited this huge legacy code base, and it can be quite daunting. We sat down to begin with and we all looked at the code, we tried to get a grasp of what was going on, we all sat there sort of independently burying our way through it, and I think in the end what helped, or one of the things that helped us sort of start us off, was we basically said, okay, so we've tried to understand the existing payment system. Let's just step back, and we all got around the whiteboard, as you can see here, and we basically said, imagine a fictional company called 8 Digital with the CEO or the main protagonist called Penny, and she basically runs a little music store, and she accepts orders for music over email. People will email her that they want a particular track or album, and they will include their credit card numbers in the email. Of course, it's purely fictional. And how would we develop a system to sort of process that? And we basically just drew sort of diagram, like basically a flow diagram, but we came up with some interesting observations about, we could make this highly asynchronous. We need to report to the record labels and other bits and bobs, but we can just do that all asynchronously. It doesn't have to have an asynchronous flow. And we identified that the approval as to whether we should allow a purchase to go through or not was actually quite important. So it was just like it was very good just to get everyone on the same page. It was a bit of a morale booster, and it sort of gave us sort of a goal and sort of a shared vision of something we wanted to get towards. We ended up thinking that like maybe we could use a message queue system or some sort of, we could add in some asynchrony.
But the important thing is this is very rough. It's about identifying the areas in the code base that you feel you need and you want to extract out, or maybe even rewrite. It gives you a goal. There's no point. It gives you a destination. Sorry, there's no point in starting a journey without a destination. So once you've got that vague destination in mind, you've still got this legacy thing, beast to tame.
Yeah. How do you tame the beast? So what we did, or one of the things we did, was we took just a very small sliver of the functionality that we sort of look after. If you can see the board here, it's the add card endpoint, and we basically, again, we got round a whiteboard and we basically went through the code and drew up what it was doing or how it was doing it. And we even got our product manager involved. So basically the whole team had this visual overview of how add card actually works. And I don't know if you can see it, but if you look to the left of the picture of the board, you'll see two crosses. And it's basically, when we actually drew this out, we realized that there's two parts of this code, this flow, that are essentially redundant. So, the value of drawing this out is that we identified, unnecessary code, so we can make a simpler code base. And, we're basically extracting the knowledge that's sort of baked into this legacy out, and we're spreading it across the team and hopefully the rest of the company.
Now, doing this and isolating knowledge and actually working out what your legacy code does can be quite important when you come to additional features. And sometimes you actually want to make use of some of the things within that legacy code. So how do we go about isolating the code?
So, your legacy code contains valuable knowledge. No, really, it does.
Yeah, so a lot of people talk about the code base being the company asset, and this isn't strictly speaking true. If anything, it's a liability for the reasons we've discussed. It's difficult to change, it's difficult to hunt bugs down, but there is an asset there, and what's really important is the knowledge contained within it. Every line of code was written for a reason, and it's understanding those reasons that's really important. So we wanted to look at actually utilising some of that knowledge. There's actually a few bits of code that are actually really useful and still work. So we decided that extracting interfaces from a particularly hefty class in our legacy system was actually really useful. So the interfaces describe the role that the legacy class was going to play in that particular circumstance. If that's too difficult or you haven't got access to the code, then maybe hiding it behind a simple API, maybe just a RESTful API or something. And again, this is to describe the role that the legacy code is going to play in your new feature. We keep the interfaces small, simple, so we're following interface segregation principle there. And we noticed that some of these classes had about 4 or 5 of these role-based interfaces on them. Clearly, we were violating single responsibility there, and it shows just how legacy code can really bloat out and why it's difficult to work with.
Yeah, I mean, I think as programmers, we are a bit afraid to, just draw pictures on boards and sort of get the knowledge out of the code. But it is the knowledge that's the asset, not the code itself. The code is just like the side effect. When it's running and making money, that's about as close to being an asset as it'll ever get. But generally speaking, it's a liability. And yeah, if you can hide it behind an API, that's really good.
So there's one other aspect that we haven't touched on yet. There's something that's got its tendrils all over the code and makes changing it difficult.
That's no moon. It's a database.
Now that's too big to be a database.
I think we're scared of databases, or at least I'm scared of databases. Even though that I think Martin Fowler's got a book on refactoring databases, we're still scared of them. And I think it's sort of compounded by the fact that often they're looked after or they're owned by a team of DBAs who have like mugs that say things like "you are wrong, developer." I am a DBA. I am always correct. They can be an intimidating bunch, but at the same time, they do have the same goal as we do. If you ask them, we've got a particular DBA here that will sort of swear at you to the end of the earth about how bad our sort of database is in some areas. So we all share the same goal. So I think it's about getting their help to basically try and sort of slay this particular beast.
But in a way, you can understand why they're a little bit protective of their database. What makes refactoring databases difficult is that the data contained within them is actually really important to your business. A lot of the financial information is actually contained within the database. You don't want to be losing that when you come to change a schema, for example. What the book Martin Fowler wrote, or co-wrote anyway, said that treat refactoring databases like you treat refactoring code. Do it in tiny, tiny steps. Doing something in small steps isn't quite as scary as trying to, for example, change the whole system over to a new database in one fell swoop.
It's not easy. I mean, just to give you some tips of what we've sort of started to do is we basically want to go to the more service-orientated architecture. So we're ultimately getting towards splitting out the databases. But by getting to that, going way back to Danielle saying, often if you change one bit of the system and it breaks a completely unrelated thing, we found that there's store procs. There seems to be a lot of store procs, and they have so much logic in them, and they seem to be shared by various different subsystems. So what we've started to do is say, okay, so you've got the store proc that powers the results page, and the store proc that powers, and it's the same that's used by some sort of sales report or something. And we said, okay, we're going to duplicate that store procedure, rename the store procedure, and just pre-append the name of the proc with the subsystem that owns it. And then we can basically start to change, for example, the results page procedure independently of the reporting one, and then we sort of minimize our risk of breaking the sales reports when we change, when we add a parameter for the results page. So that's the kind of thing we've done, and ultimately we end up with this sort of a grouping of store procedures, all pre-appended with the system name that they belong to, and it starts to get easier to pull it out into a separate system and database.
I think this is something else we're aiming towards, moving towards having smaller task-specific services that have got their own small database and they only know about the data they need to know about. Yeah, sure, to begin with we're going to have duplication of data, but there's ways of dealing with that. You can run batch jobs overnight to copy the data over, maybe have some event sourcing, or maybe even replication. But as you break the database down, it becomes a lot easier to work with. There's less data to migrate when you have to do database schema changes. Maybe a relational database isn't the best tool to actually solve the problem you're trying to solve, and you can start looking at other NoSQL solutions. Basically, don't be scared of it.
So in summary, the knowledge in the legacy code is your asset.
We can't stress this enough. Every line of code was written for a reason. Every line of code is expressing some solution to a business problem. It's reading that, extracting that, and making use of it that's important.
Repay your technical debt.
Again, don't leave it. The longer you leave it, the more the debt builds up, the more mess you've got. Repay it early and be aware of what the debt is and how you're going to repay it.
Refactor your tests.
Well, what more can we say? They're so neglected over the years because we're only just really learning what good tests are. So keep an eye on them, make sure they're fast, make sure that they're not tightly integrated into your application code. Make sure they're all necessary.
And finally, don't fear your DB. I mean, it can be scary, it can be intimidating, but if you have a DBA team, ask them for help. You will have a shared goal. They will hate it as much as you do. And just try and work for it, try and break it down, and sort of get a better grasp over it, basically. Okay.
Thank you very much.
Thank you very much. We would propose a toast to legacy code and make sure you leave a good legacy, basically. Thank you.
And if anyone's got any horror stories, hit us up on Twitter. We'd love to hear from you.
Thank you very much.
Thank you.